Welcome to this explainer. When you hear the name Archimedes, what's the very first thing that pops into your head? For most of us, it's kind of this goofy caricature, right? A bearded guy jumping out of a bathtub, running completely naked down the ancient streets, yelling, Eureka. But, as we're going to see today, just reducing him to that one eccentric moment, it literally does a massive disservice to the actual, staggering intellect of the man.
Just consider his absolute most famous boast. Give me a place to stand and I can move the earth. I mean, that is just sheer, unadulterated confidence right there. And the crazy thing is, it wasn't just arrogance. For him, this was a mathematical certainty based entirely on his own discoveries. Okay, let's dive into this and uncover the real genius of Archimedes. So, to really understand the man, we first got to ground ourselves in his world, his geopolitical reality. He was born around 287 BC in Syracuse. Now, this was part of Magna Graecia, or Great Greece, which was basically this whole network of incredibly wealthy coastal colonies heavily populated by Greeks. Syracuse itself was a prosperous, completely independent city-state, literally rivaling Athens in size. But it was also caught right smack in the middle of a super violent era, wedged between two massive emerging superpowers, Rome to the north and Carthage to the south. Section 1. The man behind the myths.
So here's the thing. Because our historical records are so fragmented, we kind of have to rely heavily on writers from centuries after he actually lived. Guys like the Roman architect, Vitruvius, or the historian Plutarch. And they love to mix historical fact with, legendary embellishments. Take that famous Eureka story. The legend claims King Hario wanted to test if his gold wreath was secretly mixed with silver, and Archimedes figured out how to test it just by watching his bathwater rise. But modern historians and mathematicians, they know this is highly, highly simplified. His actual discovery, the foundational principles of hydrostatics, was vastly more complex than just noticing water going up in a tub. He was mathematically proving exactly how different shapes float in liquids of different densities. That's a concept way too sophisticated for a simple bath observation to fully capture.
And this brings us to the ultimate irony of his life. Now, what's really interesting about this slide is the massive disconnect between his reputation and his actual passion. See, history remembers him as this legendary engineer, right? The creator of huge siege engines, death rays, and water screws. But his true passion, pure mathematics. In fact, Plutarch actually tells us that Archimedes viewed practical engineering as ignoble and vulgar. Crazy, right? He basically hated the physical, everyday machines that ended up making him a legend. Section 2. The purity of mathematics. So, while the brutal Punic Wars were literally raging outside his door, Archimedes just focused entirely on the perfect, untouchable world of abstract geometry. He deeply believed in this rational, harmonious, cosmic order. A perfect example of this is his work on the law of the lever. He methodically proved that two weights will balance on a fulcrum when their lever arms are reciprocally proportional to their size. Basically, by understanding the math, a tiny amount of force could lift a massive object as long as the lever was long enough. He even proved this directly to King Hero. He set up this incredibly complex system of pulleys to drag a fully laden massive warship all the way across the harbor, completely by himself. Talk about moving the earth.
But his true genius really shone when he started dealing with curves and infinity. He pioneered what we now call the method of exhaustion. And what this involved was approximating the area of curved shapes, like a circle, by filling them up with straight-sided polygons. By continuously increasing the number of sides, he could calculate the exact area. He was essentially laying the absolute groundwork for modern calculus. And we're talking thousands of years before Isaac Newton or Gottfried Leibniz were even born. Just incredible.
To really put his genius into perspective, just look at his precision. So the crucial point is that by using a polygon with 96 sides, Archimedes calculated the ratio of a circle's circumference to its diameter to be between 3.14084 and 3.14286. Without modern tools, with no computers or calculators, his calculation of pi was just breathtakingly accurate.
Now, out of all his brilliant proofs, his treatise on the sphere and the cylinder was absolutely his crown jewel. He mathematically proved that the surface area of a sphere is exactly 4 times its greatest circle, and its volume is exactly 2/3 of an encompassing cylinder. He was so immensely proud of this specific, perfect geometric harmony that he actually gave strict instructions for these exact shapes to be engraved directly onto his tomb when he died.
And he definitely wasn't afraid to think on a cosmic scale either. Just look at this massive number, 10 to the power of 63. I mean, that's almost incomprehensible. In a really playful yet totally profound treatise called The Sand Reckoner, he actually set out to calculate the number of grains of sand it would take to fill the entire universe. To even do this, he literally had to invent an entirely new expansion of the Greek numbering system. He was pushing the very boundaries of how humanity even understood large numbers and infinity itself.
Section 3. The Siege of Syracuse. Let's move to and see how this builds, because things take a massive turn here. Despite his total disdain for practical engineering, his beloved pure math was ultimately forced into violent service. When Syracuse allied with Carthage, it brought the full wrath of the Roman Republic right down upon them. King Hiero had previously convinced Archimedes to design defensive machines, and when the Roman general Marcellus attacked, oh man, those machines were unleashed. His defensive innovations were terrifyingly ingenious. We're talking long and short-range catapults perfectly calibrated to pummel Roman ships, hidden swinging arms that dropped massive boulders to completely crush siege engines, and these terrifying metal hooks that physically lifted Roman warships right by the prow and just capsized them in the water. There's even a fiercely debated legend of concentrated burning mirrors that he supposedly used to literally set Roman ships on fire. Through his sheer intellect alone, Syracuse successfully repelled the Romans by land and sea for years. But as you know, physical defenses can only hold out for so long against human error. In 212 BC, the city finally fell, while the Syracusans were totally distracted, drunkenly celebrating a festival to Artemis. The Romans scaled a poorly defended section of the wall, and the tragic end of Archimedes is honestly exactly what you'd expect from him. Completely oblivious to the total chaos of a falling city all around him, he was struck down by an angry Roman soldier. Why? Because he was completely absorbed in drawing a geometric diagram in the dirt, and he straight up refused to leave until his proof was finished.
Section 4. Surviving the centuries. Now, the fact that we know anything about his math today is an absolute miracle. At the time, his written treatises were so incredibly advanced that maybe a few dozen people in the entire world could even understand them. Tracing their perilous path through history is honestly terrifying. They were gathered in Constantinople in the 9th century to form what historians call Codex A. Then, those works were removed during the incredibly violent Fourth Crusade in 1204. By 1269, they reached Italy and were translated into Latin, before disappearing completely and being lost forever in the 16th century. We came incredibly, dangerously close to losing his foundational texts entirely. But the absolute most thrilling survival story belongs to Codex C, better known as the Archimedes palimpsest. Just imagine holding a 10th century manuscript containing the most brilliant mathematical mind of antiquity and then violently scraping it all away, because that is exactly what happened. Monks in the Holy Land found his brilliant geometric diagrams completely meaningless, and since parchment was super expensive back then, they systematically erased his life's work just to create a Christian prayer book. The timeline of this specific book plays out like a literal historical thriller. The prayer book was completed over those scraped pages in 1229. And it wasn't until 1906 that a scholar named Johann Heiberg realized what was underneath the prayers, using just a magnifying glass. But then, the book went missing again. It spent a huge chunk of the 20th century just hiding in a Parisian basement, before finally being sold to an American buyer in 1998. That's when modern imaging technology was finally able to reveal the lost treatises that were hiding, literally, right underneath the prayer book's ink. It's just a stark reminder of how easily human progress and foundational knowledge can be erased by time and ignorance. So what does this all mean? It leaves us with this really fascinating paradox. Was Archimedes the greatest mind of the ancient world, or was his work simply too theoretical to radically shape his own time? He was a man permanently caught between this pure universal intellect and a violent physical world. The very engineering he despised is exactly what kept his city alive, while the pure mathematics he worshipped had to survive centuries of war, fire, and literal scraping just to reach us today. It really makes you wonder, how many other brilliant ideas from history have simply been washed away forever? Think about that for a bit, and I'll catch you in the next explainer.